Hello. Today we will be presenting SOPA, a programming language we developed as a part of our SER 502 course project under Dr. Ajay Bansal. Uh, our team members consist of Vaishnavi, Shaili, Satyam, and myself, Aniket. We designed SOPA with the vision of making programming more accessible while maintaining essential functionalities. The name SOPA comes from a Marathi word which means simple in English. We have included the link to our GitHub repo as well, if you want to check out our source code. So let me walk you through the grammar of and structure of SOPA. Every SOPA program follows a fundamental structure. The program must begin with the start keyword and must end with the stop keyword. Between these two keywords, we have two main sections, declarations and commands. We support two types of declarations, var for regular variables and const for constant variables for which the values cannot be changed. Variables must start with a lowercase and can include letters, underscores, and digits. Uh, Commands and controls include assignment operator. Our assignment operator is basically colon with an equal to, followed by an equal to. Uh, we also have support for conditional statements with if then else end of structure. We have implemented loops as well. So in other languages, for will be corresponding to repeat in SOPA, and while will correspond to unless until in SOPA. We also have support for ternary operators with question mark and colon symbols. We also have support for print statements. For printing, we use show keyword to print outputs on the screen. Um, Satyam will walk you through the additional features of the language.
So hey guys, so today here I'm discussing the what are the key features that our language supports. So our language supports all the basic data types, that is integer, boolean, and string, and it will also support declaration and assignment. It supports all kind of the operations that we have, like arithmetic, relational, and logical as well. And it comes with the control structures like the if else, ternary, and loops. Instead of using for as a we use repeat in our language, and for while loop we use unless. And we have some additional functionalities added to the language as well. So modulus is one of them, and the other one is square root. And here are some sample code that we have for modulus and the square root as well. And here is the syntax overview that we have of our language. So the first and foremost is that our all the programs in our language will start with a start keyword and to end with a stop keyword. And if it has the multiple line in between the start and stop, just in the ternary operator and the nested loop, so we use the start and stop again there. And every variable names to start with alphabet. It can contain underscore and later after you start with alphabet, but it cannot start with an underscore or or a number. And here are some of the sample codes that we have, and Vaishnavi will take over.
Yes, so the compilation process of SOPA involves five main steps, ensuring that the code moves smoothly from plain text to a meaningful result. These steps include source code, lexical analyzer, parser, evaluator, and finally the output. So now let's break each step down. Everything begins with a source code, which contains the commands, variables, logical tasks that needs to be performed. The code is easy to read and well structured, making it simple for humans to understand. But to make the computer understand it, we have to go through a certain process. So the source code goes to the lexical analyzer. It is a kind of a translator that breaks the code into small meaningful units called tokens. For example, if you write const x is equals to 10, the analyzer identifies const as a keyword, x as an identifier, and 10 as a number. These tokens are building blocks for the next stage. Then comes the parser. The parser takes the tokens and check if they are valid form program by analyzing their structure. If the syntax is correct, the parser creates a structured representation called parse tree, which is shown in the picture. Once the parse tree is ready, the evaluator steps in. This is where the actual execution begins. The evaluator interprets the tree, performs calculations, evaluates conditions, and processes loops. Essentially, it's turned your logic program into real action.
So hello everyone. Now I'll walk you through the source sample codes of our SOPA language. The first problem or the first program is the addition program. As mentioned, all of the programs will start with a keyword called start and end with a keyword called stop. We have two types of variable declarations. The first one can be done through the const keyword and the second one could be done with a var keyword. The const, when you are declaring a variable with a const keyword, you have the opportunity that you can assign the variable value there itself. But while you are using var, you first need to declare the variable and then you can assign the value. So as we can see that x is given a value of 8, and then we are doing a simple addition of adding a 2, and show y will give you the output 10 printed on the screen. There is also a support for nested for loop structure. So as you can see that there is a first for loop which is given through the repeat keyword. It goes from 2 to 10, and in that there is a second loop which goes from 1 to 3. So each time the outer loop runs once, the inner loop runs 3 times. So, and as there are more statements and repeat more than one statements, we have added start and stop there also. So the output of this should be 1 2 3 1 2 3 and so on. Next, we added the support for while loop, and here the keywords are unless and until. As we can see that we have initially assigned the value of 1 to a, and as long as a is less than 10, it will show you can do this, and each time the statement is being printed, the value of a is updated or incremented by 1. The next is the square root functionality, which is one of the additional functionalities that we have added into our language. The important thing is that whenever we are doing the square root function, the number, if it's a perfect square, then it will give you the answer. Let's say here we have assigned a value of 4 to b, then the answer of show square root b should be 2. Last but not the least, we have added the if else functionality also. As we can see here that a and b are given values, and then we are comparing. So in if condition, we have a condition that a is greater than b, which evaluates to a boolean value true or false, and based on that it will show whether a is greater or b is greater. And here the keywords are if and if. So our future scope is to add the more advanced data structures like trees, graphs, stacks. We are also thinking of adding lists and arrays to handle multiple datas. And right now, string assignments are supported by the system, but operations are not. So that is something we are working on. Now, let me give you a demo of our language. So firstly, we need to download the tokenizer, grammar, and evaluator, which you can download it from our GitHub repository. After that, uh, this file soparunner.sh will take tokenizer, grammar, evaluator, and then it will convert it into a executable file when we run it in the bash with the command called chmod. And after it is converted into an executable file, you can run the soparunner.sh file and give the path of the sample program, and it will run and give out the results. So let us now try to write a factorial program. So as said earlier, we'll start with the keyword start, and then we can declare a variable, let's say a, and where r, that is for the result. We are starting from, let's say we have given the value 5 to a, that it will calculate the factorial of 5. So right now here we are using the while loop, that is unless and until. So unless a is greater than 0, what it will do is it will calculate the factorial one by one. So it will start with 5, then it will decrease to 4, then 3, then 2 and 1. As we know that the factorial of 0 is 1, so it will stop there, and when we do show r, it will give the value of 5 factorial. So now let's run this program. So as we can see, the output is 120, which means our program runs correctly. The syntax, semantics, and the evaluator, everything works perfectly. Now, if we want, we can also try it with a different value, let's say 6 or 7, and then also it will give us the result of that accordingly. So that is the presentation of our language. Thank you very much.